Stretching 5.5 kilometers into the Arabian Gulf lies the most audacious engineering project the world has ever seen. Palm Jumeirah. The rocks are immediately piled onto barges and shipped straight to the construction site. It takes less than 24 hours for each rock to travel from quarry to breakwater. 24/7, this floating conveyor belt delivers up to 40,000 tons of rock per day, nearly the same weight as 2 aircraft carriers. The density, size, strength and permeability of each boulder is crucial. The job is found 6 nautical miles out at sea. This sand is much more suitable. It's coarse, packs densely, and is more resistant to wave impact. They will dredge sand from the Gulf seabed. And there is an added benefit. The dredgers will spend less time transporting the material to the construction site. In just 3 hours, a dredger travels to and from the site, scoops up the sand, and sprays it into position. It works a 5 square kilometer area, dredging up the top meter of the sea floor. It takes less than an hour to fill the 8,000-ton tank with sand. The sand is then pumped through a pipe and sprayed into place at 10 meters per second, enough to fill an Olympic swimming pool in 4 minutes. The process is called rainbowing. The island construction team work round the clock to keep to the tight schedule. Night and day, the island grows bit by bit. The rainbowed sand builds into a sandbar, rising up to 4 meters out of the water. But for the engineers, there are mixed feelings. There's steel holding these rocks in place. These vast boulders are not just dumped in position, graded by size and weight, it's the sheer volume that keeps them here. Positioned by cranes, each rock must interlock with the next to withstand the full force of the sea. Constant checks are needed to ensure the breakwater is in the right place and the rocks are stable. The only sure way to do this is to send in divers to pinpoint and check every meter of it. Nothing about this megastructure is left to chance. Any movement could cause the rock to crack and the wall to disintegrate, leaving the whole project vulnerable. A detailed study of the breakwater rocks below the water is noted. Divers are looking for signs of fatigue on these 6-ton boulders. Their fear is that some will have splintered or been knocked out of place by strong waves when they were put here. Every 27 meters, a diver surfaces to record the location of the rocks they're checking. The reading is taken from a man based on 48 degrees Celsius. So far, humidity, it's 95%. With heavy packs strapped to their backs, these mobile receivers create a grid reference for the island. Receiving signals from space and a fixed position on land, the height and position of the sandbars is recorded. With these coordinates, dredgers can sail into the exact position and rainbow the sand with pinpoint accuracy. Only by using
sand one drain upon another. If we put the ocean around it, you see the island. However, the lateral forces of an earthquake can make the island disappear.
This terrifying phenomenon is called liquefaction. It happens when a quake shakes the Earth's surface, causing sand particles to move. As the sand compacts, it pushes the water between the particles upwards, making the ground liquefy. It means the island would sink back into the sea. January 2004. 15 machines work around the clock to firm up the land. Probes drill over 200,000 holes into the ground across the surface of the island. High-pressure water and air drives each probe deep into the earth. This shaft then vibrates, shaking the ground around it. The earth is compacted. It's a tried and tested formula. As the sand compacts and sinks, more sand is added every year. This 1.6-kilometer stretch will carry at least 8,000 villa and apartment complexes, 220 shopping malls and restaurants, and the developers are still threatening more. A new plan is the 36-story Palm Tower. More space for shops, restaurants, and 450 deluxe apartments. But all this extra development comes at a price. The deadline for the trunk has slipped